All right, guys, welcome to part 3, arithmetic sequences and series. A sequence in which the difference between successive terms is called an arithmetic sequence. The difference is referred to as the common difference and is denoted by D. All right, formulas to know for this section. So if you're finding the nth term, so if they're telling you to find the 6th term or the 48th term, you'll use this formula below. A of n is equal to A1 plus n minus 1 times D. All right, and then the other one is the sum of finite arithmetic series. All right, and that formula is shown by S of n, whatever that amount may be, n over 2, A1 plus A n. Now, this could be more important. These formulas are going to come in handy when you are finding much larger sums. If you're finding the sum of like 4 numbers, that can be fairly easy to do. However, if they want the sum of like the first 200 numbers, you would want to use these formulas rather than having to solve it 200 times and then go back and add it all together. All right, so determine the common difference and then find the next 4 terms of the arithmetic sequence. So first things first, common difference. If it's a common difference, that means it's the difference between every number. And we can just find that by solving. Let's see, negative 36 minus negative 53. The difference is 17. And you could have obviously just looked at these and go, oh, what's the difference between 53 and 36? 17. What's the difference between 36 and 19? 17. And you can just find it that way as well. And then, so because of that, we then find the next 4, which we'll just do by math. Negative 19 plus 17 is going to give me negative 2. Plus 17 is going to give me positive 15. Plus 17 will give me 32. Plus 17 will give me 49. And those are the next 4 terms. All right. Find the 65th term of the sequence. Again, this is one of those situations where you would want to use the formula above. All right. So we have to find the 65th term, which means we're finding the nth term. So we're going to use this formula up to the top left. So I'm going to write it here. AN is equal to A1 plus n minus 1 times D. Well, first thing is we need to find what D is, which is, we know A1 is 11. N in this case is 65. And D, which is the common difference, 11 to 4, okay, we went down 7. 4 to negative 3, went down 7. So that's going to be a negative 7. All right, so then let's go ahead and plug it all in. A of 65 is equal to A1, oh, not 1, which is 11, plus n minus 1, which is 65 minus 1, which is 64, times D, which is negative 7. You can plug this into the calculator. You'll get that A of the 65th term is equal to negative 437. So that means that the 65th term in the sequence is going to be negative 437. All right. Find the first term of the arithmetic sequence for which A, 44, is equal to 229 and D is equal to 8. So now we're going backwards. They've given us the 44th term. We have to find the first term. So we're still going to use the same formula. We're just going to plug in different numbers and we're going to solve for something different. So we know that A44 is equal to 229. A1 is what we're looking for. And and they've already given us in this case as 44. Okay, so A44 is equal to A1 plus n minus 1 times d. Okay, so I'm going to go ahead and plug in 229 as A44, and then A1 plus 44 minus 1, which is 43, times d, which they've given us as 8. All right, so that gives us 229 is equal to A1 plus 344. This is simple algebra at this point. We'll subtract 344, and that will give us that A1 is equal to negative 115. Okay, example